Hello everyone, I'm back with a brand new protocol which is J1939. On this channel, we share content related to automotive engineering, vehicle electronics, and diagnostics. So, if you enjoy such topics, do like, subscribe, and tell me in the comments which automotive topic you want next. Now, let me ask you something. What if I told you your truck has a nervous system? Yes, just like the human body, a truck also has a system that allows all its parts to communicate, and that system is called J1939. In today's video, we will cover what is J1939, what is CAN, why was J1939 needed when CAN already exists, flow of data through J1939, and how communication happens with real life example. So let's get started. J1939 is a standardized communication protocol. You can imagine it as the nervous system of a truck. It connects all the electronic control units and allows them to talk to each other. But you might ask, why do we need a standardized protocol? So let's find out. Inside a truck, there are many ECUs: engine ECU, transmission ECU, ABS ECU, dashboard ECU, and many more. But here's the problem: these ECUs are often made by different companies. Each company uses its own communication method, so even though all ECUs were connected, they could not understand each other. It was like people speaking different languages in the same room. So we can summarize it like this: no common language, which is equal to no communication. So to solve this problem, J1939 was introduced. It gave all ECUs a common language. Now it doesn't matter which company made the ECU, they can all understand each other. Messages are no longer just numbers, they now have meaning. So we can say one standard language equal to seamless communication. So to sum up, J1939 is the language of ECUs. It defines what a message means, who sends it, who receives it, and how to decode it. That's how modern cars, buses, and heavy vehicles communicate reliably and safely. Moving forward, let's first understand what CAN is. You can imagine CAN as the nerves of a truck. In automotive terms, CAN is the network that carries data between different ECUs. It does not care what the data means, it only makes sure the data is delivered fast, safely, and without errors. Now, the question arises: why do we need J1939 when we already have CAN? The answer is simple: CAN only carries the data, but J1939 gives meaning to the data. For example, CAN may send a value like 0x2A, 0x10, but J1939 tells us that this value actually represents engine speed of 1720 rpm. Without J1939, the message is just numbers. With J1939, it becomes useful information. Okay, now let's move on and see how data flows through J1939. So first step is ECU creates the data. Then data is placed in J1939 message. Message is sent on CAN and others ECUs decode and use it. Let's see a real world example. So when you press the accelerator, the engine ECU measures speed, which is suppose 1720 rpm. Data is placed in J1939 message. Message is sent on CAN. Transmission ECU receives it. Similarly, ABS ECU listens and dashboard ECU displays that RPM. Thank you all for watching this video. I'll see you in J1939 part 2, where we will go deeper into PGNs, SPNs, and the J1939 frame format. Make sure to subscribe so you don't miss it.